Hi guys, my name is Ivo and I'm from mytestedasp.net. In this video series we are going to cover ASP.NET Core Web Security Considerations, and in the first lesson I'm going to talk about Sql Injection. In case you're not familiar, this topic was chosen by my community on Patreon, where I constantly upload exclusive video lessons like optimizing web applications, database indexes, data structure efficiency, and so on. So if you're interested in advanced C# lessons, make sure you check it out. Good, now let's begin. Let's see what we're going to cover in this series. First, I'm going to talk about common security problems. Then I have some demo code for showcasing how we can attack a vulnerable application with very common web application attacks. For example, Sql injection, parameter tampering, cross-site scripting, cross-site request forgery. I'm also going to talk about some other threats which are commonly used by hackers. So the common security problems we need to think about when we implement our web applications are listed here. There are more, but they are more rare. So first we have Sql injection, which I'm going to cover in today's video. But Sql injection essentially means that if my application is vulnerable, you can inject SQL code and execute unwanted queries on the database. We have cross-site scripting, which means that instead of SQL code, I can inject JavaScript code, which is also problematic because with JavaScript code injected into a foreign site, I can easily store cookies and gain unauthorized access. URL HTTP manipulation attacks or parameter tampering. If a developer is not very careful, he may leave some models and some classes vulnerable for changing their data, which may not be the desired result. We have a cross-site request forgery, which allows a hacker to use his own site to steal cookies and make unauthorized requests. For example, calling your bank account without having an actual access to the bank account. And the user may not be aware that an attacker is currently stealing his money or something like that. We have brute force attacks, which is essentially denial of service attacks, which is the DOS. This means that I'm flooding the web server with so many resource requests that the web server becomes no longer is able to receive and execute requests, is no longer responsive, and is unable to work properly. I may have insufficient access control, which essentially means that if some user if my code is not written correctly, I may leave unauthorized requests which may be attacked later. In ASP.NET Core in particular, I may leave some post requests or some GET requests available for anonymous users. And that may lead to a problem because if an attacker finds out that a current route is not protected, he may use it to gain some information. Another common mistake is too much information in error pages, for example, stack traces, exception messages, and everything that may help an attacker gain more information for the server. Public configuration too. There are multiple GitHub repositories on which you may find connections to an actual production database. If you search on GitHub, you will find a lot of mistakes like that, which essentially means that the database is public. Man in the middle attack or missing HTTPS or SSL, which means that our connection to the server is not encrypted, and if somebody decides to join our network and sniff our requests, he may gain access to our password, to our credit card, and quite a lot of other information. So it's important to always have SSL and HTTPS on our site, because if we don't have these options, our all the user information is sent in plain text, and when it's sent in plain text, you know, an attacker may sniff on the network and gain access to the user information. Phishing and social engineering. Phishing and social engineering are attacks which are uh, more like knowing your victim, more like I'm familiar with the victim. I know, for example, her cat's name, and I may try to guess the password by um, by knowing its cat's name, or try an easy password, a not very strong password. I may try to guess or understand the victim more to think how she may decide to choose her password, which is kind of problematic, because if our users are not careful, we cannot protect our application. We cannot do anything but warn users to use stronger password, to turn on two-factor authentication, and so on. Because by using social engineering, a lot of accounts can be easily hacked. Another thing is phishing. By phishing, what I mean, phishing is sending an attacker a similar website to the original one. For example, sending the victim to paypal.com dot something else, and the whole design is copied, everything is the same, everything looks like the original PayPal. And if I send an email to my victim saying something like, hey, you have pending balance, you need to approve it, you need to do something, you need some sort of an action, you have a lot of money, somebody sent you money, or something similar. And what may happen is that the user will not see that the email is not coming from paypal.com, but is coming from a similar domain. And when he opens the website looks the same, and the website wants his password and his username. So the user, without understanding that he is not on paypal.com, enters the username, enters the password, and this is how the attacker now knows the user's PayPal password, which is kind of scary. And last but not least, we may have security flaws in other software we use. For example, we use third-party library. There is a problem in .NET, for example. There's a problem in ASP.NET Core, and so on. So there may be security flaws in other software, and we need to constantly update it and read through the release notes to make sure that there is no security vulnerability in our application. Good. Now let's talk about Sql injection. By default, Sql injection means that through the inputs in a form on our website, the user may send a SQL query which can be executed on the database. And this way the user may add a new administrator, the user may delete data, the user may alter data, and essentially that's a huge vulnerability, because it takes some trial and error to guess the data tables knowing the business domain, and by guessing these tables, the attacker may gain access to sensitive information. So by default, object relational mappers like Entity Framework Core protect you from these kinds of attacks. So if you're using an ORM, you're safe. But if you're using a SQL query directly in your code, if you're using raw queries in Entity Framework or in Dapper or by using the Sql Command class, you may need to protect your queries for Sql injection. Consider the following query. If you have select everything from messages where message text like something here. And if this part of the query comes from a user input, this query can be transformed to match all entries like this. Select everything from messages where message text like. We hit in the input to close the text and then say or 1 equals 1 dash dash, this is a comment in SQL, and then it doesn't matter what the rest of the query in our code is. So this query will make SQL Server think of search for message texts where the text looks like this or is true. So essentially SQL Server will return all entries available in the database. And these entries may be sensitive and we may not be authorized for them, but by altering the SQL query we can do that. Or we can use it to insert new data. For example, select everything from messages where message text like, and again we close the like string and then specify another query which is insert into messages something new, and again dash dash at the end to comment the rest of the query. So essentially we're transforming the original query to add additional queries to it which are not authorized, for example inserting data, fetching data, and so on. We can even get access to a poorly written database if we are a little bit clever, and with a little bit trial and error we may guess the other table names. For example, in ASP.NET Core Identity, the table names are, and the default table names are these: ASP.NET rows, ASP.NET user claims, ASP.NET user rows, ASP.NET users, and it will be very easy for an attacker to guess what the names of the tables are. And what we can do is, for example, if we try to search for a user to log him in, for example, validating his password, validating his username, we can say something like string query, select everything from user where name equals the username and password equals the password. Of course, that's very poorly written validation check, but believe me, a lot of websites don't have any security protection and they're vulnerable, which is kind of sad, but it's normal because developers don't understand every single aspect of security, every single aspect of ASP.NET Core, and sometimes they make mistakes. So setting the username to John and the password to or 1 equals 1 produces the following query. Select from user where name equals admin and pass equals empty text or 1 equals 1, which essentially will allow the database to fetch the admin account with any password. So we can log into the admin without any password, because the query will turn into a Boolean expression which will be always true, and that's problematic. Good, now let's go to the code and see the vulnerability in action. I have prepared a demo for all the common attacks, and in the security controller we can find different kinds of attacks. But before I show you the code, let me show you where you can find that demo. Just go to my GitHub profile, which is Ivailo Kenov. You may follow me if you like. Go to repositories, write down TV, and this is the repository I'm using for my YouTube channel. Every single lesson is linked here, and all the source code is added here. So you may download it, you may open a pull request, you may fork it, you may do whatever you like. It's completely free. I will appreciate if you give the project a star. That will be huge from you. And if you want, you can watch the repository, because this way you will be notified every time I upload a new video lesson. So in the source folder, web application security consideration is the folder with the code. I'm going to use the moment to thank all my sponsors. That's Endeavor, 2K, Softuni, Smart IT, Noble Hire, and 1-Bit Software. Thank you guys, you truly rock, and you truly motivate me to continue working on my YouTube channel. Endeavor is IT company which is constantly searching for passionate developers. So if you're currently looking for a new career opportunity, make sure to check their website out. My other sponsors are 2K, Softuni, Smart IT, Noble Hire, and 1-Bit Software. Thank you guys, you truly rock. Now let's get back to the code. So for a Sql injection, we don't need a lot of things. We need a view, which is here, just a normal input search button, search input, and a button for submitting the form. In the security controller, our search is implemented by using raw SQL queries, and it's not protected. It's exactly the same if we're using Dapper. So be careful, guys. Just be careful if you decide to use raw queries. Here it is. Select from data values where name like the search text. I'm using an interpolated string here, which is the problem. This is not protected. So if I run the code, look how easy it is to hack this query. If I enter the following, you can try with everything else, but if I enter the following, or you may try to drop the table, just complete the search text and then hit a semicolon, and you can write whatever query you like. Then what you need to do is write dash dash to comment everything after this query. It's very easy to manipulate data this way. Here it is. If I go to the web page and hit Sql injection and hit the malicious query, I'm going to write search. I'm receiving some data, which is the original data from the database, but if I try to search, if I go here into data values, I will see that there's a new one which is called hacked named hacked value. That is essentially the value I added. Here it is. Hacked name hacked value. So I used a search text to add new data into the database, and that's a huge problem. That's problematic. I can also use a drop table. I can say union select everything from some other sensitive data table, and if I try to guess the database design, I can find a lot of sensitive information by using this technique, and that's where we're using interpolated strings, and essentially it's not protected. How to protect that? What's the correct way? The correct way is to use parameters on our command. Parameters on our command is execute Sql command. To use parameters in our command, okay, yeah, so that's the one way, and the other way is by using direct execute SQL command on the database. So the proper way is to have parameters like this one. Parameters in SQL are marked with the @ symbol, and if we want to protect ourselves from SQL queries, what we need to do is we need to create the query with a parameter and then add a parameter like this. Add the search text from the web application to the parameter. This is how we protect ourselves, and this way C# will escape any SQL injection an attacker may try to use. So this is the correct way to save ourselves. So create a command, provide the query with the parameter, then add a parameter and add the value there. This is protected. You can also use execute SQL command by something like this, and then it wants to receive parameters. Search text SQL parameter, where we need to provide the text name and the search text like this. Both ways are completely fine, using SQL command or using the db context execute SQL command. It doesn't matter what you will decide to do. The important thing is, let me return the original code. The important thing is to make sure that you're not using plain SQL with interpolated strings. If you write it like this, it's also not okay. This is also a problem. So never write query parameters directly into the query. Always use the provided SQL injection protection mechanisms to protect yourself from SQL injection. Okay guys, that was for the first video lesson about SQL injection and about common vulnerabilities. In the next video I'm going to continue with the slides, and in the meantime make sure you check out my Patreon if you're interested in additional exclusive lessons about advanced concepts. Thank you guys, bye.